So, the parts of a right triangle, the sides adjacent to the right angle are called the legs. The side opposite or across from the right angle is the hypotenuse. So if I look here, this side and this side are the leg because they're adjacent to the right angle. The hypotenuse is across from it. You need to know these. If you can't identify the parts, it's going to be wrong. So, what are the parts of the triangle called? Lowercase a is the / a blank. Try and do all four by yourself. A is a leg. B is a leg. C, lowercase c, is the hypotenuse. And upper or capital C is the right angle. So, triangles that have hypotenuse leg matchup are congruent. Hypotenuse leg only works for right triangle, so you still need three pieces of information. Two sides, a hypotenuse and a leg, and you need to know it's a right triangle. If you have those three things, you can say it's congruent. So, if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and the leg of a second right triangle, then the two triangles are congruent. So if these two sides and this angle match up to these two sides and these two, then this angle, well, in this special case, we can now say these two triangles have to be congruent. One thing that I noticed I just messed up a little bit here. Yes, angle C and angle F are right angles, but I probably should have said triangle BAC and triangle EDF are right triangles. Because if I look at the condition up here, it's a right triangle. Not that there is a right angle, but that it's a right triangle. So, segment AB and segment DE match up, segment AC and segment DF match up. So the hypotenuse of a leg in one triangle, hypotenuse of the leg of another right triangle, these two triangles have to be congruent. Hypotenuse leg congruence theorem. So now I have three things available to me. Side, 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 angle, side, and the special case of side, side, angle, hypotenuse leg. Those are the only three things I can use now as shortcuts to say that two triangles are congruent. With everything that we know, decide whether enough information is given to prove that the triangles are congruent using the hypotenuse leg congruence theorem. Well, if I look in number 1, I have a hypotenuse and a leg marked as congruent to a hypotenuse and a leg over here. No, not even a chance. The reason is because it's not the corresponding part. I have the hypotenuse of one triangle be congruent to the leg of another, and I have the leg of a triangle be congruent to the hypotenuse. No, the corresponding parts of the triangle do not match up. In fact, this scenario is impossible. These two triangles cannot be shown to be congruent. In fact, they can't even be possible. But yeah, there you go. In the second one here, I have a leg matched up to a leg. I have a hypotenuse matched up to a hypotenuse, and I know they're right triangles because of the right angle symbol. So therefore, these two triangles are congruent by the hypotenuse leg theorem. Because I have a hypotenuse matching up to a hypotenuse and a leg matching up to a leg, and they're both right triangles. And the last one, prove. I realize some things didn't get hit in, but that's fine. I like flow proof, so that's where I'm going to start. The only thing I told you for sure is that segment AB and segment BD are congruent. So I wrote it there. Given. Also in the diagram, if I look, angle A and angle D have been marked as right angles, so I can use that. First thing, angle A and angle D are right angles. Yeah, I think that's a good choice because it's marked in the diagram. So let's think. I have segment AB and segment BD being congruent. I have that these are right angles. Okay, so two sides in right angle. Oh, my guess is because it's right angles, it's going to be a hypotenuse leg. And if I look, segment AB and segment BD are both legs of their respective triangle or corresponding triangle. Segment BD over here is the leg, segment AB over here is the leg, and those are both right angles. So I have leg and right angles. Well, I'm probably going to say something here about a right triangle. It's not just enough to say angle A and angle D are right angles. I have to say that the triangle ABC and the triangle BDC, this is wrong. Please correct it. It's triangle DCB are right triangles. And the reason is definition of right triangle. So now all I need is to get their hypotenuses congruent. The hypotenuse of triangle DBC is segment BC. The hypotenuse of triangle ABC is segment BC. Wait, both hypotenuses are segment BC? Why don't I just say segment BC is congruent to segment BC, reflexive property? Now I have hypotenuses matching up, legs matching up, and these are right triangles. So those two triangles are congruent by the hypotenuse leg congruence theorem. This is technically wrong. I'm going to switch it real quick. Yeah. And there's a corrected version. So what I corrected was this right here, triangle DBC, or triangles, triangle DBC over here, and the hypotenuse leg congruence theorem. You can actually prove it. I'm not going to prove it though. So there we go. This is what I expect you to be able to do. If you're trying to show triangles are congruent, you now have three tools: side, 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 angle, side, and hypotenuse leg. Those are only three ways that I would try proving triangles are congruent right now. If you're trying something else, you're probably doing it wrong. Unless, of course, you're in section 5 and you're using angle, side, angle, and angle, angle, side. Well, that's all for today. So, till next time.